on this computer. I'm sorry about that. So these are the changes from that second progress report. So we decided not to do a test flight, and we did that vacuum chamber testing that I just mentioned. We have updated our fin flutter calculations just slightly based on the actual thickness of things, something like that. The flight simulations and masses were updated just a little bit. Those didn't affect the simulations drastically. We did increase our drogue to a 3-foot diameter drogue. This gives us a little bit of margin on and allowed us to slow down that descent while still being pretty quick. It didn't greatly increase the recovery zone, the wind blowing with the wind. So we decided that extra amount of speed arrestment before we deploy the main probably would help lower the stresses in that environment and ensure that doesn't break anything. We also extended our shock cords to 40 feet for a similar reason. Deployment charge testing increased our black powder charges. We just did this the other night, where we found that the amounts that we had originally thought weren't quite enough. So we increased these to 6 grams for the booster and 7.2 is the backup for the booster. And then the upper stage or the upper segment, 3.5 grams and 4.2 grams. So we'd love to show you all the rocket if you'd like, or if you have any questions now, whatever you think is best.
I guess the main question I've got is this doesn't look anything like report 2.
Okay, how so?
How so? Report 2 talks about tender descenders, LCD displays, no details on payload. It was only going to be dead weight payload.
I'm not sure. We've never been looking into tender descenders, nor have we looked at LCDs.
They're in your report.
Is that for Liberty? Are y'all Liberty?
Well, I guess the comment is that I didn't look at your first report, but based on your second report, this is an entirely different rocket. Secondly, you talked about MissileWorks as your altimeters. Now you switched to something else.
We've never been considering a MissileWorks altimeter. We've been using the Enticore and Egg Timer. We did originally look at another one for the very first one, but we chose
you are Team 52, Liberty University, correct?
We're Team 151, Washington and Lee University.
Oh, my mistake then. Okay, my mistake.
No worries.
Okay, cool. I'm glad. Then that's my mistake. I grabbed the wrong one. I know that they're also a similar team. We're actually helping them transport some stuff out to New Mexico. So we're looking forward okay, my mistake then. My mistake.
No worries.
Then, given that, I guess it must be Monday morning and I'm still talking. Okay.
No worries.
This looks really nice. This looks really nice. That changes things around a lot. I'm glad you're able to do the flight testing and get the results that you've gotten. I'm trying.
Hey, Ben, if I could jump in with a couple of questions before we go to the rocket.
Please.
Yeah, can you I didn't see the slide numbers. Can you go up about actually go to the top and just flip down and I'll remember what I saw. Okay.
Yeah.
Okay, down. Next. Okay, on the avionics, go back to avionics sled.
Yep.
Up one.
Yes, sir.
Okay, I noticed you have a primary isolator switch on your Enticore, but you didn't do the same thing for your egg timer.
That's correct.
All right. The other thing, my thought is, you have a single. For example, when you look at dual redundancy, is your primary isolator switch a possible single failure mode that would disable both your primary drogue and main from your Enticore? It's one switch that is affecting both circuits. That's
not quite correct. So
okay.
This terminology is difficult. I acknowledge that. All 4 of these switches are individual switches. So one of these switch failures would cause the primary system to fail or the secondary system, depending which switch it is. So there's 4 switches on board the rocket. We would need to power all 4 before flight. So the primary power switch powers the entocore. Primary isolator switch allows that current to get from the entocore to those charges. Those are 2 separate switches, and those are on one side of the rocket. On the other side of the rocket, we have the 2 switches for the egg timer. So one of those is a power interrupt switch, we did that because the egg timer supplies power through the igniters all the time. Even if the normal on-off switch that it supplies is on, and the continuity lights light up, which that's something we didn't want, not only for battery drain, but also because we don't want to be applying any current to those igniters while we're messing with them, while we're working on those charges. And then that secondary on-off switch on the egg timer is the standard switch for the egg timer, which turns everything on. So any,
okay,
I'm sorry.
Yeah, no, I'm following. So yeah, I guess my words weren't exactly good either. So yeah, you do have dual redundancy there. Just my thoughts on you have one switch that could affect both the drogue and the main charges coming in for entocore, but you're correct. You have the dual redundancy there, and I'm following how you're doing the safing. Okay,
we can go look at this if you'd like to see it in person. And it might
be something good as we go through the rocket. Okay, next slide.
Yeah. Okay, we'll stay there.
Unless you had something there.
Stay there. Does not the entocore aim include a GPS?
It does not. No.
Okay. Okay. Yeah, there.
Yes. So this GPS is up in our nose cone. We chose to put it up there for it to be far away from any sort of metal components, so, and it was also a good spot for it.
Okay. How
All
is? Go ahead, Lee.
Oh, just a thought on your 5 dBi antenna. I know the testing you did might have given you some additional range, but when it comes to antenna patterns, you're getting the gain at the sacrifice of coverage. So you kind of squeezed it down to a little area.
Okay.
Just a thought. A flight of a rocket is very dynamic. When it's going up, you will have your pattern will go out more and with a higher gain antenna instead of down more.
Okay.
It's just a few dB. It shouldn't be a big deal, but just realize that increasing gain on antenna works only in a nice clean line that is stable, and your thing's gonna be flopping around a lot. And when it lands on the ground, if it were to have more gain off on a certain lobe, that lobe is not pointing towards you guys. It's not that big a deal. Just a thought.
Yeah. Well, we still have the standard 2 dBi stub antennas that it comes with. We can change those easily if that's something that you recommend.
Yeah. Do you have any RF geeks on the team?
We have one. I'm not sure he'll be able to make it. He's not here today. Talk to him about it.
If they did an antenna class, that not a big deal. Just a thought. Okay, Ben.
Perfect. How you'll probably show us, but how is that secured in the nose cone so it's not going to fall out?
Yes. So this sled here and these 2 aluminum rods, and we'll take a look at this here in a second, slide up through the nose cone and are retained by this aluminum upper bulkhead, which is glued inside the nose cone. And then the payload slides in, and these little tabs right here on this green tab, if you can see it here, and we'll see this more closely when we go look at it physically. That slides inside the rocket, and then the payload comes in, keeping it there.
Okay. All right. Scroll. I don't think I
think I had one on the next slide.
Yeah. Go to the next slide for us.
Yep.
What percentage of your additional weight is your total payload?
I'm not sure off the top of my head. We're still working on some extra batteries for the GoPros. Those haven't come in yet, so we're waiting to weigh them. We're looking at between 20 and 40% right now.
Okay.
But that may change, so I'm not sure.
Yeah, it won't be too bad. And that's secured in the payload section, will not come out.
Yes, so it's secured on the bottom by the bottom bulkhead and on the top by that GPS sled with those 2 aluminum payload retainer plates.
Okay. Is it going to be positioned in the rocket flipped 180 degrees so the payload weight is towards the motor?
No, we weren't planning to. So
okay, you have to show us. Okay, show us that.
So this would be in the orientation that it would be inside the rocket with the additional weight on top.
Okay. How are you protecting the GoPro lenses and stuff?
The GoPros are housed within a 3D printed housing, which we actually have some of that in the other room, a test of that. So these GoPros are fitted within this 3D printed frame.
Okay. All right.
All right. Next slide.
Yeah.
Your ground tests, when you did the ground test with your original black powder charge, what was it that you saw that you thought you needed to increase it more? What did you see that made you change your mind?
Yeah, so we had been talking about this with Chuck before, of how we had thought that those might have been a little bit low. We did them with the original amounts. Both deployments, both drogue and main, did occur. We did actually shoot them out, but they were not shot out with authority. We did shear both shear pins, but they kind of flopped out, and we wanted a little bit more oomph to get them out of there.
Okay. Good. All right, next.
And this was an extra slide on the motor just for some additional information we needed.
So. Okay, that's all the questions I had at this time.
Great.
Yeah. Let's see the rocket.
Awesome. So I hope you'll be able to see this. So here's the rocket.
If you can do us a favor and cut down, close the slides up, then we see a lot better.
Great. Yeah. Dave, would you mind?
Better.
Okay, great. So here's our rocket. We have it in our stand right now. So we have our fiberglass nose cone with the aluminum tip. These are the camera holes right now. We're working on the acrylic pieces that go inside them for the windows. Those are still in progress. We've had to do a couple of iterations. This section here, from here to here, is our upper segment where the main chute stays within here. Our avionics bay is here. It's a coupler-based avionics bay, so it goes 6 inches up on either side with vent holes. And then this is our booster section where the drogue is here, the motor is within here, and then the fin can at the bottom.
Can you show us the motor retention system?
Yes. So right here we have an aluminum thrust plate, which is adhered inside that fin can unit, which in the slides we saw that. It's threaded for 632 screws with this water jet cut aluminum retaining plate. This white 3D printed piece is a representative motor in here, so it's secured in there. The motor is not here at current.
Where is the motor?
The motor's stored at an off-campus location because we can't have it here.
Oh, okay, but you do have it.
Yes, we do physically have it, and it's
okay. Okay.
Yeah,
what are you planning on using for an igniter?
So we have 2 igniters. We have dual igniters. We have 2 of them each. So we have, and Chuck recommended these. They were, I can't remember what they are off the top of my head, but we got the large ones and the second largest size because we weren't sure, and we have 4 of each of those.
You're not going to put 4 igniters in there, are you?
No. We just had extras because extras are good.
Okay. All right. Let's move up to the electronics bay payload area.
Great. Yeah. So we've split out the electronics bay here. So these are the internals inside the avionics bay. So you can see that these two bulkheads fit onto the coupler. So if there would be a coupler here, but obviously we couldn't see it if the coupler's there. So this is our electronic sled, so the end-to-core aim and the egg timer. You can see how we've disabled the egg timer buzzer and replaced those with a series of LEDs. These are the screw switches here, these cones. I don't know if you can see those very well. We've added 3D printed cones to allow us, when we stick our wrench in, to be able to fit those easily while we're on the pad. And then the batteries are mounted on the back within a 3D printed battery sled holder, which is secured on the other side with 2 bolts. You see those nylon bolts right there, so that the batteries cannot come out in any direction. The entire thing rides on these 2 high-strength stainless steel rods, which also secure the avionics bay shock cord attachment rods from either end.
Okay, talk to me about your charge wells. They look like they're 3D printed.
Yes, they are. So they're ABS 3D printed. All parts on the rocket that are 3D printed are either ABS or SLA resin. We extensively tested these charges. As you can see, these are actually from the deployment charge testing. We took one of the charge wells, we filled it up as much as we could with black powder and tested that 3 times. And so there was 3 different charges that we tested, and they survived quite well with no visible melting of the plastic or burning at all.
Okay. What kind of shock cord is that? Black coiled up?
Yes, so this is Kevlar. It's 5,300 pounds, I believe. So it's we purchased from Rocketman Parachutes. We have 40 feet of, this is the drogue harness, and then this is the main harness over here.
Okay. Looks like it's basically brand new.
It basically is, yes.
Good. Because that will be one of the questions that when you go through safety at New Mexico that they will double check on, is make sure the shock cords are in good shape.
Great, yeah.
Deployment bag.
Yes, so we have
parachute.
a bag for our 14-foot main parachute. It's in there. It's kind of big, so we didn't unpack it. And our drogue, our 3-foot drogue here, is black in color. And then we have an extra large Nomex wadding to protect that, as well as take up some of the space within that upper body tube, simply because there's a lot of room up there.
Okay. All right. Now let's head back towards the rocket.
Before you do, can you flip it over and show me how the batteries are mounted again?
Yes. So the batteries are mounted here.
Flip it over so it's horizontal so you can see it.
Yeah, all the way.
There you go.
There's the 2 batteries are mounted here within this ABS 3D printed piece. This piece is secured to the rods, to the steel rods, and then the batteries are unable to slide out of it because of these nylon pins here, these nylon nuts.
And can you show me the part where the ABS connects to the rods?
Yes. Let's see.
Different.
Yeah. Okay.
Can you see that?
Yes.
All right, thanks.
Awesome.
Okay, back down to the rocket, back down to where the rocket splits apart.
Yep.
Right there. Well, or go down a little bit further. No. Where are we at here?
So this is the nose cone to upper section connection, where there's a 6-inch coupler, like the nose cone shoulder. And then there's a 12-inch avionics bay coupler within this section.
Okay, where are your altimeter portholes at?
So these holes right here, these are I'm not sure if you can quite see them. We're still working on some of the painting of the rocket and cleaning up these holes. We need to work on the paint. The paint got real messed up around those holes.
Okay.
So we have 3 1/4-inch holes going around the diameter of the rocket.
Oh, that ought to be plenty. Okay. All right. I just wanted to make sure that the holes weren't below the line as the separation point as opposed to above.
Yep. So we have small holes here for the shear pins, and we'll also have vent holes for both sections, but we haven't drilled those yet.
Okay, so this is a fiberglass based rocket, right? With fiberglass couplers?
Yes, sir.
Okay. All right. This looks really good. Sorry, my mistake about looking at the wrong set of
No worries.
sorry, Lee.
No, it's fine.
But anyway, it looks pretty good. You've hit all the main points that I think you're gonna encounter in New Mexico. You know, you will have to take the rocket apart in New Mexico, so don't come with shear pins installed and all that sort of stuff.
Understood.
Yeah, because they will ask you to take it apart and they will look at everything
Great.
from top to bottom. So I got, you know, they'll double check to make sure everything's secured and all that sort of stuff. So okay. 15 buttons, correct?
Yes, that's correct. They are right upper, and then the lower is down here.
Very good. All right. Lee, I'm good.
No, pretty straightforward. I don't have any other questions.
Yeah, I think I think you guys have done a nice project. I'm going to reverse the role here and let you guys or gals ask the 2 of us any questions you've got about Spaceport or the contest or anything like that.
That would be great.
General questions.
It's our first time attending this competition, so we're quite excited, but we also don't quite know what to expect.
A zoo. How's that sound?
Well, in a good way. One of the
Yes.
things. So one of the things we would like to ask is anything that you all think that we might need to know, and whether what that is, especially for a first-time team logistically. How does that work? Is there anything that we should know that's significantly different from a standard launch, or otherwise?
I guess if a standard launch I guess if your standard launch were to exceed 1,000 people, then it's a little different.
Understood.
Right. Okay. Let me give you a little bit of statistics. We're expecting somewhere between 120 and 130 teams. The average number of people of teammates per team runs between 8 and 10. So you can do the numbers.
Yeah.
It is New Mexico. It is June. It is going to be hot. Probably the lowest temperature will be 90. It could get as much as 120. So electronics bays sitting out there do cook a little bit.
Yeah.
So you're going to be aware of those sort of conditions. The same goes for your clothing.
Yep.
You're going to want to make sure that you're sunblocked and protected against the sun. It is a very dry heat.
Understood.
It catches up with you very fast. And drink plenty of water. The old things about drink plenty of water, et cetera, et cetera, et cetera. And we'll have all that stuff at the site. The rockets and yourself will be transported out to the pads. I think we have 30 plus 3 times, maybe 24 to 25, somewhere around in there. What we call solids pads.
Okay.
We have a half a dozen 2-stage flights, and about 12 to 15 hybrid flights, I think, coming up. We have no liquid flights. The flying areas, the pad areas are separated out so we can load and fire without interrupting the flow. We will control the firing of the rocket, obviously, and so on and so forth. There will be food trucks, but I would advise bringing your own food unless you want to eat the greasy stuff off the food trucks. It's going to be live streamed, so somebody may shove a microphone in your face and say talk.
Okay.
Doesn't sound like that'll be a problem. Generally, rockets transported out to the pads are either on one of our transports, or you can take your car and load it up or whatever you've rented to get there. The distance to the launch site from the hotels is about an hour drive.
Yep.
Please don't necessarily believe your GPS. Follow the pavement, because if you wind up going with your GPS, it will shortcut you through roads that are not paved, and
Gotcha.
you'll get stuck, pretty well guaranteed. Again, it's a desert environment. Don't wear sandals, wear real shoes and stuff. There are thorns that are 4 inches in length that will puncture the bottom of a sole. You don't want to wind up with that sort of stuff. Okay.
One question on the logistics there. One of the Liberty team was unclear whether or not there was tents provided, like pop-up tents in the student
No.
assembly areas. We need to bring our own.
We provide you with a 10 by 20 space.
Awesome.
On gravel.
Great.
So you need to bring your own support. You need to bring a tent. You need to bring tables or whatever you need. A lot of the teams hit Walmart.
Great.
And again, it depends on how you're transporting stuff and how you're getting there. As far as the contest goes, Monday is registration.
Yep.
All team members need to be there to go through registration. Be sure and bring your AAA cards with you.
Okay.
And as we have advised several other teams to download your virtual card from AAA, so you got it on your phone.
We'll definitely be doing
that. Once you've gotten through registration, then the Monday afternoon and Tuesday are inspections.
Mhm.
And I think Tuesday is also the podium area and all that sort of stuff.
Yep.
On that end of it. And then Wednesday, you head out to the launch site. Morning is prep time. We start flying Wednesday afternoon. We generally shut down 5, 6 o'clock, I think. Resume flying on Thursday. Flying is available on Friday, although it's only available on Friday morning.
Okay. Do the winds pick up particularly bad in the afternoon, or is it relatively stable across the day?
Actually, the winds are dying. There's no wind in the morning. There's a lot of wind in the afternoon.
Gotcha.
So fly as soon as you can. There's also points that are awarded based on,
Yep.
What time you fly. If you're able to get off on Tuesday afternoon, you maximize your points for flying.
Understood.
If you're if you're getting off the rail by Friday, then you're not going to get any points for flying, for instance. Okay, so
Great.
you'll designate a certain number of recovery crew. The recovery crew will be put through a quick class on what's expected. You'll be given some gear, and you'll be tracked out there, so we know where you're at. But again, plan on trudging through sagebrush, thorns, and who knows for how long. So
Understood.
the recovery crew really needs to be prepared. Bring your rocket back.
Yep.
Make sure that they record the data in terms of altitude, condition of the rocket, and so on and so forth.
Yep.
The majority of the stuff at the contest will be marked out. There'll be a tent for check-in and all that sort of stuff. So you'll be able to go from there.
Great. Well, thank you so much.
That's a good, I think, again, plan an hour from the hotel. So
yep.
On that end of it. So, and I think you have to leave the range by 7 in the evening. So
great.
Any other questions?
Any questions?
I'm gonna try to shoot this with a camera. Are there rules about putting a camera closer to the rocket, and are there some rules about how you can remotely trigger those cameras?
There will be a couple of the team members will go out to the pads to mount the rocket on the rail and turn on the electronics and all that kind of good stuff. If they want to, yes, they can leave a team camera out at the pad if they wish to do that. And they do come back, and there is a lost and found, so it happens every year. But yeah, no, you can put your own camera out there if you want to.
Okay,
great.
And again, the intent is to live stream the whole contest. So
yes,
great. Yeah,
we'll
definitely see that. Colin, Thomas, any questions?
Off the top of my head, pretty clear here. I guess like the only thing that I would ask about would be kind of the timing. You mentioned like trying to make sure that there's a good flow. In years past, have certain like stands gotten installed? Are we going to anticipate there might be like a time where we're waiting, or we get like stalled with another two that function? Is that typical, or are things like really pretty smooth throughout?
I didn't quite. Can you maybe get closer to the mic and repeat that for me? Sorry.
Sorry.
Oh, pardon that. We had on the mobile phone here. I was just asking, you mentioned kind of a pretty smooth flow of operation of teams being able to get off on the pads. In years past, do you guys anticipate, or has there been kind of like maybe periods of where we're waiting for a significant amount of time in between launches? My only kind of question with that is just like, with the electronics getting pretty hot in the sun, do we think that our rocket could be like stalled on the pad for a significant amount of time, or does that not really happen?
Hopefully the launch will go smoothly, and there won't be much wait time, but there is definitely going to be some. And it's hard to tell right now. We've definitely increased the number of solid pads. And we've made it such that the hybrids and the two stagers will have minimal effects on the launching of the solids. So, you know, it's hard to tell. I mean, it truly is. Some of the wait time that you'll encounter, and you won't have your electronics on, will be you'll be in the line to go out to the next series of launches and stuff like that. Once you're on the pad, it should go relatively fast. But
Okay.
you know, if I was designing it, I would say plan for up to an hour.
Yeah,
That would, you know, I would hope that would be worst case.
Yeah.
Best
Okay.
case would be a half hour.
Yeah,
It's going to take time to clear people away from the pads, all that kind of stuff. So
everything but the payload has a really long life, and we're working on that one right
That's
now.
good. Perfect. Sweet. Thank you, sir. Appreciate your time.
Great.
no, it's our pleasure. I apologize for grabbing the wrong
No worries.
the wrong documentation. But your rocket looks really, really good. Chuck and I know each other for many, many years. So you guys are good to go. I can't think of anything. Word of advice, get there as early as you can Monday morning and get in registration line. If you don't, you're going to be behind at least 1,000 per you know, so it's going to take a while to go through registration.
Great. Yeah. So,
Okay.
all
Great.
righty.
You can stop the recording, and my fault for not reminding you to record. I'm real bad about that. And secondly,